This is the test 1 review. We're going to start with this first question, which asks us to simplify the expressions. When we simplify the expression, we have to make sure we follow the order of operations. The first thing that we do with order of operations, it says parentheses, but what parentheses really means is the groups. So the group we have here is this 1 minus 5 first. So 1 minus 5 is -4. So that's the very, very first step. Then we have exponents. So -4 squared is 16. Because we have squared everything inside the parentheses, we no longer need the parentheses. After we do the exponent, we do multiplication or division, whatever comes first, left to right. So then that's this 3 times 16. And then we do the addition. 48 plus 16 is 64. All right, the next question, question B, is a little bit different because I have something in the numerator and something in the denominator. When that happens, the numerator is grouped together and the denominator is grouped together. So that means that we have the group on the top. So we need to simplify that and simplify the bottom. So on the numerator, we start with 6 squared minus 15, so we need to do the squared first. That's 36 minus 15. In the denominator, we have parentheses, so that's a group within a group. So we have 2 minus 6 is -4 plus 4. Okay, we can simplify the numerator here. 36 minus 15 is 21. In the denominator, 5 times -4 is -20. And then we still have to add the 4. So -20 plus 4 is -16. So we get 21 over -16. Now we don't like putting the negative in the denominator. That's technically not the prettiest way to write it. So we just make a positive over a negative is a negative, and we just make our whole fraction negative. And that is our simplified expression. All right, this next question on the first page, it says solve the linear equations. So we just need to solve them. To start solving, we want to simplify the expressions that are on either side of the equal sign. So in that case, we want to simplify this expression on the left. We need to distribute the 4 through. That gives us 4x minus 24 plus 19. And then we can add the -24 plus 19 would be minus 5. So 4x minus 5 is the left side. The right side, we have 6. We need to distribute the -2 through. So -2 times x is -2x. -2 times +1 is -2. So that would give us 4 minus 2x on the right side. Okay, now we want to bring any x onto one side and everything else over to the other side. So I'm going to add this 2x over to the left side. If I add it on the right side, I have to add it on the left side. So that gives us 6x. I'm also going to take this 5 and bring it over by adding 5 to both sides of the equation. So that gives us 9 on the right side. Now we just need to divide by 6. And we get x equals 9/6, which can be reduced. So make sure we write them in simplest form. So x is 3/2. And there we go. All right, the next question has fractions, so we want to get rid of those fractions. That's the very first thing we want to do. So if we find the LCD between 6 and 4, we know that that is 12. So I can take each term in my equation and multiply it by the LCD. So I would take that 1/6 and multiply by 12, the 9/4 and multiply by 12, and the 1/4 and multiply that by 12. What that does is it eliminates all the denominators because I can multiply them. 12 over 6 reduces to 2 and 1. So that just gives me 2 times x. On the second part, the 4 and the 12 reduce. That gives me a 3. So that's 9 times 3. And then the 4 and the 12 reduce again. 1 times 3 is 3. Okay, now we have the exact same value of an equation with no more fractions. So then we can just solve that. 2x, let's subtract the 27 over. That's negative 24. Divide both sides by 2, and we get x equals negative 12. And that's our solution. All right, this last question on this page is an application problem. So it says you are choosing between two plans at a health club. We have Plan A and Plan B. Plan A offers a membership fee of $75 and you have to pay $15 per month. Plan B offers an initial membership fee of $20 and we have to pay $26 per month. So we've got initial membership fee of $20 and we pay $26. Here, initial membership fee of $75 and we pay $15 per month. And then we want to find how many months are the two clubs the same price. So that's what we're trying to find. So how many months is probably the most important phrase there. Our x is going to be the number of months. That is what we are trying to find. So we're going to write expressions for Plan A's total and Plan B's total cost using x as the number of months. So we have an initial fee in Plan A of $75. And then we also add $15 per month. Well, the per month is represented by an x because that is the number of months. Plan B offers an initial membership fee of $20 and then we pay $26 per month. We want to find after how many months are these two the same, means we just set them equal to each other and we solve. So I'm going to solve this equation by subtracting the 20 over to the left side and subtracting the 15 over to the right side. And if I divide by 11, we get 5 equals x. So that means after 5 months, the total cost is the same. All right, so that is our question completely answered. Question 4 is set up kind of weird because there's a question on the test that kind of wants you to look at a problem and solve the problem or try and figure out what is wrong with the problem that somebody else has solved. So these questions kind of help you set that up and recognize this. So the question says here, solve the inequality and write the solution in interval notation and graph. Answer the questions about the inequality. So whenever you have a question where it wants you to recognize a mistake that somebody else made, the best thing that you can do is solve it yourself first and see how you go about solving it. So what you want to do, I'm going to do that. I'm going to go through before I answer all these questions, and I'm going to just solve this inequality. So the first thing we want to do, like we're solving the equations, is simplify the expressions on either side. So I'm going to distribute this 9 through, subtract the x. So that gives me 6x minus 5 is less than 8x minus 27. I will add the 5 to the 27 and then subtract the 8 from the 6x. So that gives me negative 2x is less than negative 22. Then I need to divide both sides by negative 2. And because I divided by a negative, we need to make sure that we flip the sign. That's a huge mistake I see a lot of people make. So we need to be very careful that when you divide or multiply an equation by a negative, we flip the sign. So we have our graph. Here's our 11. It's an open circle, and its x is greater than 11, so there we go. And that's our graph. Our interval notation is 11 to infinity. Okay, so now we have the answer. We're going to go through and answer the questions that they ask us. So it says, what is the starting point of x? So we go through and we solve this equation. We are actually starting at 11. I call that the critical value. So 11 is the starting point. Now, they ask us, is that boundary point inclusive or exclusive? So do we include the critical point or not? Now, because we are less than or greater than, we are not equal to, we are exclusive. We are excluding it. Okay, so that means that we are going to have an open circle. Okay. The next question is, how do we know the direction the inequality is going? Because x is greater than 11, all the values 11 or bigger are included in that phrase. So 12 is greater than 11, 13 is greater than 11, and so forth and so forth. So that means our graph is going to go to the right. Okay, so what does the graph look like? We're kind of just going to copy and paste what we did over there. We have 11, it's an open circle, and it's the values going right. And the interval notation just reads that graph. We start at 11. We do not include 11, so we use a parenthesis. And then because we go on forever, it goes towards infinity. And the last thing that is asked in this problem is, what is a common mistake that can be made when we're solving inequalities? Well, there's one big common mistake, and I think that this is going to give you a huge hint in the actual test, the mistake that the student is going to make. So when we divide by a negative, we must flip the inequality. Simple. That is the most common mistake I see. There's a couple other sub-mistakes, but they don't directly link to inequalities. For example, up at the top, not distributing the 9 all the way through the problem. So being careless with distributing is another common mistake I see, so be aware of that. But other than that, not flipping the inequality sign, hands down, biggest mistake on inequalities. So probably a chance that the student that you're going to look at will have made a mistake like that. The next questions are absolute value equations, not inequalities, but absolute value equations. So when we're solving an absolute value equation, the first thing that you want to do is isolate the absolute value and especially make sure that there's no addition or subtraction. So here's my absolute value right there. We want to make sure that that 15 is over on the other side. So we have 9x minus 1, and I'm going to subtract the 15 to the other side. After I do this, this is probably the easiest problem on the test review because our absolute value cannot equal a negative. There's no solution. And there we go. The second question in this, same idea. We want to isolate the absolute value by, let's subtract that 4 over. 13 minus 4 is 9. Now I can do this one of two ways from here. I don't have to isolate the absolute value with multiplication and division. I can break my absolute value up and then distribute the 3. Or if I want to, I can divide both sides by 3. I think in this case, it's easier to do that because 9 divided by 3 is a clean number. If that were like an 8 divided by 3, I probably wouldn't want to do that because I don't want to have a fraction that I don't need. So the other option would be to distribute the 3 through. So we have two equations from here. We have x minus 1 equals 3 or x minus 1 equals negative 3. And we solve each of those equations and we get our solution. X is 4 or x is negative 2. You can write your solution like that. You can write your solution x is 4 and negative 2 like that. Either way, it works. All right. The last one is probably the most tricky one. Okay, but don't get caught up on it. What you can do when you're solving an absolute value inequality or absolute value equation like this is you can actually you can change those absolute value symbols to parentheses and then say that the inside of that left side can equal the positive of the right side, or the inside of my left side can equal the negative of my right side. So I've set up my two equations, and then let's go ahead and solve each of those. So 2x minus 7 equals 6x plus 4. Let's see, that's a negative 4x equals 11. Or positive 11, sorry. Negative 4 over negative 4. And that x equals negative 11/4. On the other equation, I need to distribute the negative sign through. I'm going to add that 2x over, that gives me 8x, and add the 7 over, that gives me 3. And then we're going to go and divide both sides by 8. We get x equals 3 over 8. So my solutions are negative 11/4 and 3 over 8. And neither one of those reduce, so that is our answer. Okay, question 6 says, given the absolute value inequality, let's answer the questions. So the first thing that they say is, what is the first step in solving this inequality? Now this is very important. We must always isolate the absolute value with addition or subtraction. So I'm going to make sure that I add that 4 over to the right side. That is unbelievably important for your test. Make sure that you bring that 4 over first. Now, after you do that, we can go to step B. How do you write the two inequalities from the absolute value? So if you remember, we want to break that up into we can say 9x minus 3. If that were an equal sign, it would equal 6. And it would be 9x minus 3 equals negative 6. So on the positive one, we keep the sign the same. And on the negative one, because we multiplied that 6 by a negative 1, we need to flip the sign. So we have two signs. We write it with the positive, keeping the sign the same. With the negative, we flip the sign. Now, we are asked, do we include or exclude the boundary points? Because we have a less than or equal to and, a greater than or equal to or a less than and equal to, we include the boundary points. That means that we will have a closed circle. Okay. Now, from here, we are just asked to solve the actual inequality. That's kind of nice because we did already set up the two inequalities that we need to solve. So, I'm going to solve this first one by adding 3. So 9x is greater than 9. And then I divide both sides by the 9. X is greater than or equal to 1. Notice on that, I divided by a positive 9, so I do not flip the sign. So we have x is greater than or equal to 1. On the other side, I'm going to add the 3 over, that's negative 3. Divide both sides by 9, we get x is less than or equal to negative 3/9, which is the same thing as x is less than or equal to 1/3. So if we look at the graph, we have certain boundary points. The first boundary point we have is x is greater than or equal to 1. That would go to the right because greater than means to the right. X is less than or equal to negative 1/3. We also will include that, but it's less than negative 1/3, so that's going to the left. So there is our graph. And after we get the graph, it's pretty easy to get the interval notation. We just will go from left to right there, left to right. So reading that interval, number line left to right, we start at negative infinity to negative 1/3, include the negative 1/3, and then from 1 to infinity. And both the graph and the interval notation is the answer to the problem. And they will ask that. They will say, write the solution as a graph and as an interval notation. So there we go. That is solving an absolute value inequality. Okay, question 7. It says, given the relationship, state if it is a function. Now, we don't need to write the domain or range here. If it helps you write it out, you may. But really, if we want to decide if something's a function or not, we just need to see, does every x have only one y? So here I have 3 goes to 7, and 3 goes to 9. 2 goes to 6, negative 1 to 4, and 5 to 5. So right here is our problem. We can't have that. So this is not a function. Okay. Now on the homework, you may need to actually list the domain values and the range values. But on the test, this is a multiple choice type of question where you would just click, yes, it's a function, no, it's not a function. So on B, we have negative 3 goes to 7, negative 4 goes to negative 7, 4 goes to 6, and 3 goes to 7. So since every x has only one y value, this is a function. Definitely a simpler question, but this would be an example of something that would be multiple choice type of question because you should be able to just look at the problem or do minimal work to get what they're asking. Same thing with 8. These would be a pretty simple type of questions. This would be a multiple choice type of question. It says find the slope between the points. So something that you will absolutely need to have in your head is the slope formula. So my slope equals y2 minus y1 over x2 minus x1. I'm going to label my points. Okay, so we have our slope is equal to y2, which is negative 5, minus y1, which is negative 4, over x2, which is negative 2, minus x1, so minus negative 6 is plus 6. That gives me negative 9 over 4. And since we can't reduce that, that is our slope. There we go. Let's look at the next question. So we have y2, which is 7, minus y1, which is also 7, over x2 minus x1. So that is 0 over 2, which happens to be just 0. Because our slope is 0, that's a horizontal line. Okay, this next question asks us to find the domain and range of the function. So let's use that. That's fun. We're going to first find the domain. So the domain has us look at the x value. So we're reading it along the x-axis. I like to think of taking all the values and mushing it horizontally and seeing what's happening. So if we do that, here we are starting at x equals negative 5. So if we're looking at our domain, we're starting at x equals negative 5. Right there, that's the x value. Then we have something, we have something, we have something all along the horizontal direction until we get to right here. That's where we would stop. Well, the x value where that stops is at 9. But because it's an open circle, we just do a parenthesis so that we know that we can't be equal to. All right, finding the range, it's a little bit different. So here, this is our y value. Our range is our y. So we're going to mush everything together and see what it does vertically. So the y value that we're starting at is negative 8. Because it's an open circle, we can't be equal to it. So we use a parenthesis. And then we have something, because there's all this stuff here. So we have something. Here we're overlapping, but that's okay. We have something. And right there is where we're stopping. We're stopping at 9, y equals 9. Because it is not an open circle, we can be equal to that value. We only use open circles on our domain if we're not equal to the value. If it is an open circle, parenthesis. So that's finding the domain and range. Now this is a problem where you're pretty much just looking at it to decide what's happening. So it's a little bit harder type of multiple choice question, but this would still be a multiple choice because you should be able to do it quickly once you get the idea. All right, 9 has, I think, 4 questions. It says, what is the slope of the given graph? So if we want to find the slope of this graph, I'm going to zoom in a little bit. And I'm going to find some points where it's going through perfectly. So it's going perfectly right here, and let's say right here. Okay, now each of these boxes represent 1. So that's rise 1, rise 2. So my slope, if I do the rise over the run, we rise positive 2, and then we run 1, 2, 3. So 2/3 is our slope. All right, the next page is going to have the rest of the questions of this problem. These kind of got pretty big so that we could really see what was happening. That would be a definite multiple choice question because you're really just looking at the graph and doing the rise over the run. So let's look at B. Let's zoom in a little bit on B. That is a vertical line. So if you wanted to calculate the rise and the run, you can. But hopefully by now you realize that vertical lines, the slope is undefined. Okay. So there we go. That's our answer. Our slope is undefined because we have this vertical line. All right, with horizontal lines, kind of similar. So we have a horizontal line. Our slope, on all horizontal lines, our slope is 0. So we have our horizontal line. Slope is 0. Okay, and the last one here. This line is different than all the other ones because this is decreasing. So if we look at this one, the hardest part on some of these is just looking how they're doing their tick marks. So we can do this a couple ways. I noticed this point and this point right off the bat. There are other points that can be used that also work. But I thought these are good ones to work with. So here's a little triangle that represents the slope of the line. So on my slope, here, I'm going to calculate the rise and the run. I'm actually going down 10, so I'm rising negative 10. So that's negative 10. And running positive 2. So that means my slope is negative 5. Sometimes I get asked the question, can I go from the right point to the left point? And it's absolutely. We are actually here rising a positive, so that's positive 10. But then we're running negative 2. Positive 10 divided by negative 2 is also negative 5. So it doesn't matter which direction you go, it will work out. So it was a decreasing line. That means my slope was negative. My positive line, my slope was increasing. And then we have the horizontal line is a 0 slope. A vertical line has an undefined slope. All right, that was a good page. There wasn't very much on that one. We've got 2 more pages to go. So question 10 says to find the slope of the line parallel and perpendicular to the given line. So the very, very first thing that we want to do here is solve this equation for y. So we can do this a couple ways. I'll just do it this way. I'm just going to subtract the 3x over and then divide everything by negative 4. So we end up with y equals negative 3 over negative 4 is 3/4 x, and 12 divided by negative 4 is negative 3. So here is our line. The slope of the given line is 3/4. We need that information to find the parallel and perpendicular lines. So the parallel line, its slope is the same slope as the line that was given. The perpendicular a little bit harder, but remember we flipped the fraction and changed the sign. So instead of 3/4, it's 4/3, and we use a negative. So there we go. We'll actually use this problem on a future problem on the test review. It looks like on question 12. So just kind of keep that one in the back of your mind. Let's go on to question 11 though. So question 11 says use the points to answer the question. I should say questions. The first thing is, what is the slope of the line? So to find the slope of the line, we just go y2 minus y1 over x2 minus x1. So 15 minus 5 is 10. Negative 2 minus 3 is negative 5. So that means my slope is negative 2. Okay, after we find the slope, the next thing they want us to do in this problem is find the equation of the line. Now this is important, and I get a lot of students that will miss this because they're not reading the problem. It says find the equation of the line in slope-intercept form. Now this is a pretty big problem. There's a lot of steps to it. So this would definitely be a written question. So you can write this on your note sheet, y equals mx plus b. Slope-intercept form means y equals mx plus b. Okay, so we can use either point. I'm just going to use the point 3,5 because they're both positive. So we first find the slope, but we did that. Then the second step we do is we put it into y minus y1 equals m times x minus x1. So y minus the y point, which is 5, is equal to my slope, which is negative 2, times x minus the x point. Then we solve this for y. So I'm going to distribute the negative 2 through, and then add the 5 over. And there's the equation of our line. Okay, the last thing that we are asked to do on this question is to graph the line. Now, if you were asked to graph the line on a test, the coordinate system will be given to you. But that didn't happen here, so we'll just sketch out the coordinate system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So there is our coordinate system, and we're going to graph the line. So it's y equals negative 2x plus 11. So here's my y-intercept. So I just made it go up to my y-intercept so I didn't have to recount them out. And then here's my slope. So if it's negative 2, that means negative 2 over 1. That means we are going to rise negative 2 and run 1. So rise negative 2 means go down. So go 1, 2, run 1. Run 2, run 1. And assuming that we can draw a nice straight line, the graph should look something like that. Okay, so there's graphing our line. You should start feeling pretty comfortable with that. It's just very easy if you have it in slope-intercept form. You just plot the y-intercept and then apply the slope. Okay, question 12 and 13 are going to use question 10. So remember I said we're going to go back to that. So it says write the equation of the line passing through the point 2, 5 and is perpendicular to my 3x minus 4y equals 12. So we solved that. We found that y equaled 3/4 x minus 3. So the first thing that we need to do is we need to find the slope of our line. We're given the perpendicular line, but we need to find the slope of our line. So let's find the slope. Okay, so we have the 3/4 is perpendicular. So that means our slope, the line that we're looking for, is the -4/3, which is what we found above. So that's good news. Now, after we find that, we need to, I'm using a thinner pen because I think I'm going to need a little more space. We're going to use this y minus y1 equals m times x minus x1. So I'm going to put my slope and the point here into that. So we have y minus the y point, so y minus 5, is equal to my slope, -4/3, times x minus the x point. Okay, let's distribute that -4 through. So that's -4/3 x plus 8/3. I'm sorry, this is actually step 3. We're going to start solving. So I'm doing that. I distribute the -4 through. I'm just making sure that I did everything right. Now we just add that 5 over. And we need a common denominator. So the common denominator we have here is this 3. So I'm going to multiply the 5 by 3 and the denominator by 3. So that gives me -4/3 x plus 8/3 plus 15/3. So we've got y equals -4/3 x plus 23/3. Yeah, just check and make sure that 8 plus 15 is 23. Okay. After we do that problem, let's go ahead and go on to 13, which is a very similar problem. The only difference here is that we are now looking for the parallel line. So the first thing we do is we find the slope. We know that the slope of the line parallels 3/4, so our line is also 3/4. After we find the slope, we put the information into point slope form. So we have y minus 5 equals 3/4 times x minus 2. And then we solve for y. Still fractions, but that's okay. We can deal with a little fractions. We're going to distribute 3/4 times -2. That's -6/4, or we can say that is -3/2. So we add that 5 over. And my common denominator here is this 2. We're not worried about the 4 because we're only adding the -3/2 and the 5. So I'm just going to go 2 over 2. So that's 3/4 x minus 3/2 plus 10/2. And that gives us our final answer of 7/2. So y equals 3/4 x plus 7/2. Okay, so finding the equation of the line, there will be a couple problems where you need to do that. It's one of the harder things from this section, so just make sure you're getting that down. My recommendation is just making sure that we have the 3-step process. We find the slope, we plug it into y minus y1 equals m times x minus x1, and then we solve for y. because whenever we're writing the final answer to the equation of the line, we want it in point slope form. So that's solving for y. We did it. We got to the last page. The last page here has an application problem that I think is a very simple application problem. It says Henry got a new job. The annual pay for his job follows the linear function y equals 34,000 plus 3,500x, when x is the number of years Henry has been working for the company. So y is the annual pay, x is the number of years. Y can be replaced as a function notation, so instead of a y, you might see f of x. Just keep that in mind. You should know that those are interchangeable by now. So what is his starting pay? That is his initial value. So his starting pay would be the y-intercept, which is 34,000. How much does his pay increase per year? That is the slope. That's the rate the pay is changing. So that is my slope. So that would be $3,500 per year. Okay. Now, the next questions are a little bit harder. It says, how much will Henry's annual salary be after 20 years? When I have a problem like this, I like to say, okay, how much is his annual salary? That's my y value. After 20 years is my x value. So I like to decide what is my y value versus my x value that I'm trying to find. So my y value is equal to 34,000 plus 3,500 times the 20. All right, if you do the math on that, you will get $104,000. So after 20 years, his pay is going to be $104,000. Pretty good. All right, and then the last thing is, how many years must Henry work to have a salary of $93,500? So how many years? That's actually our x, and we are given the y, or the f of x. So we know our y is 93,500, and that's 34,000 plus 3,500 times x. And x is what we are going to try and find there. So I'm going to subtract the 3,400 over. That gives us 59. Oh, my pencil turned off. 59500 equals 3,500x. And if I just divide that by 3,500, I get x equals 17. So that's 17 years. It will take the teacher 17 years, or Henry 17 years, to earn a salary of $93,500. So that's really just what we would say a plug and chug. You just plug it in and you chug along and get going on it. So it's very simple. You just plug it in and that's it. Make sure you know what value is going where. I think that's the hardest part of these problems. Okay, the last questions on here is solving the system of equations. You can use any method you want. It says you can use substitution or the addition/elimination method. If you want to graph it, you can graph it also. I wouldn't, because I think that's the most imprecise way to do these, but it is a way to do it if you want. So it says the first methods, we've got 3x plus 2y equals -8, and 2x plus 5y equals 2. So I'll do this one using the addition method. We call it the addition method because we can line up the equations and add them. So we want to eliminate one of the variables. It doesn't matter which variable, you get to choose. So we can get rid of the y's or the x's. On the test review, on the written test review answer key, I got rid of the x's. So let's get rid of the y's here so we can have two different things happen. So if we have that, let's just see here. I want the 2y and the 5y. I want to find the least common multiple between 2 and 5. That is 10. And we want one of them to be a negative. So I'm going to multiply the top one by negative 5 and the bottom one by positive 2. Because 5 times 2 is 10. 2 times negative 5 is negative 10. When we add 10 plus negative 10, that's 0. So that will help us eliminate the y's. So if I rewrite these equations out, I get negative 15x minus 10y equals 40, and 4x plus 10y equals 4. Okay, now if I add these equations together, I get negative 11x equals 44, and I divide both sides by negative 11, we get x equals negative 4. I obviously did not give us enough room on these problems. That's okay. Now, we found x, but that does not mean we are finished with the problem. The solution to a system of equations is a point, an x value or a y value. Sorry, an x value and a y value. So you have to keep going. And you can use any equation to keep going. So I'll just take this equation here. And we have our x is negative 4. So I'm going to plug in I plugged in the negative 4 for x. That's negative 8 plus 5y equals 2. I add that 8 over. That's 10. Divide by 5. I get y equals 2. So my solution here is my x value and my y value, but they need to be together. So I personally like writing it as a point where we have the x value, then the y value. And there is our solution. I'll highlight it because the work kind of it was messy. So we got that. There's our solution. Okay, the next question, I'm really going to zoom in so that we can have more space. So I have 3x minus 7y equals 20 and x plus 5y equals negative 8. Now we can do this a couple ways. We can use substitution or elimination. Substitution or the addition method. Sometimes I call the addition method elimination method because you're kind of eliminating a variable. The easiest way is that method, the addition method. Because I can just take this equation right here and multiply it by negative 3, and it gets rid of our x. So let's do that. Now, a lot of people will like the substitution method on this because we can just subtract that 5y over. That is also a fully perfect, great way to solve the problem. Okay, but if I do the addition method, I can add these together. Now I get negative 22y equals 44. I divide both sides by negative 22. And I get y equals negative 2. And then we can use any equation to find our x. I'm just going to use the bottom one. We could use this equation, this one, or this one, so it doesn't matter. So I'm just picking this one right here. I'm going to plug that -2 in for my y. So that's x minus 10 equals -8. So x equals 2. So that means my solution is 2, -2. A point. You can also write your solution as x equals 2, y equals -2. I really don't like it when you don't put those points together. Like you have one somewhere and then you have all this work and then the other answer somewhere else. Those do go together, so you want to write them next to each other. All right? So that is our substitution again. Let's do one more C here. Let's try substitution on this one. I think it is in a better substitution form. So I'm going to just take this 4x and subtract the 7 and add the y so that I can solve this top equation right here for y. So I brought the y over and brought the 7 over. Now I have 2y equals 8x plus 15. All right, let's see. We know our y is 4x minus 7, 8x plus 15. Now notice with the substitution, I now have an equation that no longer has 2 variables, it just has 1. That's the point of substitution. So if I distribute this 2 through 8x minus 14, 8x plus 15, if I subtract the 8x over, we're in trouble. -14 equals 15. That is a lie. -14 does not equal 15, so that means that there is no solution. It's kind of nice when that happens, because you don't have to do any extra work. But also it's kind of sad when that happens because it means you did some work for nothing. Okay, so just a couple things about this test. Remember, if you have a number in front of your parentheses, whether it's positive or negative, you're distributing everything through to those parentheses. If you multiply or divide by an inequality by a negative, make sure you flip the sign. And just be careful with your work and you'll do great. All right, good luck on this test. If you have any other questions, you are more than welcome to come and talk to me. Especially on Monday, I will give you some time in class to ask me questions.